we will continue the solution of the CXC CSEC May 2019 paper. And of course, number 7 is the one that most students and teachers had difficulty with, especially this section of the question that has to do with the first 8 terms of a sequence with nth term un, and we have the first 8 terms presented there, and they are 1 and 1. Of course, the first 2 terms are equal to 1, then the third is 2, 3, 5, 8, 13, and 21, and so on. Now we have here that u1 is equal to 1, u2 is equal to 1, and of course, for any term for which n is greater than or equal to 3, un is equal to un minus 1 plus un minus 2. Now, just by looking at it, we might be overwhelmed by the expressions and the terminology. But if we take a second look at it, then we will realize that the entire thing is pretty much very simple. Now, if we have un, which is the nth term, n minus 1 would be the term that is 1 less. The term that is 1 less will merely be the term before. And then we have un minus 2, which is the term that is 2 less than the present term. So in all, what we have here, as we see it explained here, if we have u5, or we may say it is u of 5 as expressed in the terminology or jargon of functions, where this would be read u of 5 is equal to u of 4 plus u of 3. Now, all that it means is that the 5th term is equal to the sum of the 4th and 3rd terms. And, you know, to make it easier, we have a second representation of it, where the 7th term is equal to the sum of the 6th and 5th terms. So, it is not difficult to see. Term 5 plus term 6 will be equal to term 7. Term 3 plus term 4 will be equal to term 5. So there is really no difficulty. Before attempting to solve the problem, let us take a look at the implication of the general form on the synthesis of each term. That is what we have just done. Although it is already demonstrated in the statement of the problem, yes, we will do that, although it is demonstrated in the statement of the problem. We look and we see how each term is constructed. After the first 2 terms, then any term after that will be the sum of the 2 terms preceding it. And you can see right here, 1 plus 1, that's 2. 1 plus 2, that's 3. 2 plus 3, that's 5. 3 plus 5, that's 8. Right, so that's a special sequence that we will finish up by taking a very good look at. Now, to continue to simplify the implication of the general form and the synthesis of each term, let us show this with our animation. We will choose a number that is greater than or equal to 3 and see how other terms are generated. So, greater than or equal to 3. So let us choose 6 because we have 5 and 7 here. Let us choose 6. So, u6 is equal to u6 minus 1 plus u6 minus 2. And even before the animation shows it, you will see that u6 will be u5 plus u4. 6 minus 1 will give you 5, and of course 6 minus 2 will give you 4. So by now there's nothing, or there should be nothing abstract about how we arrive at each term. As we also have it right there for n is greater than 3, we see that each term is the sum of the two preceding terms. The demonstration is for students to whom it might seem a bit abstract. So the examiners imagine earlier on that if it is left like this, maybe in algebraic form, it might seem to be a little bit abstract. So what they have done is that they have given us two examples of what they really mean when they say that un is equal to un minus 1 plus un minus 2. Now, let us answer the first part of the question. There's no need to go through all of these because we discussed that on the previous slide. Write down the next two terms in the sequence, u9 and u10. So the next two terms will be u9 and u10. Of course, we know that we have up to u8 right here. So we need u9 and u10. So label each term to make for easy reference. We are going to just label all of these terms. So when we need to add in order to find u9 especially, it will be easy. So u9 is the sum of the two terms preceding it. So we have u9 is equal to u8 plus u7. And we have all of the terms up to 8 right here. Therefore, u9 will be equal to 13, which is u7, and we will add u8, which is 21. So u9 will be the two terms, the sum of the two terms before it, which are 8 and 7, term 8 and term 7, and those are the two terms, and the result is 34. Then we will find u10. And of course, you imagine that if we need to find u10, that the u9 that we just found will be a part of the sum, because that will be the sum of u9 and u8. So u10 is the sum of the two terms preceding it. So u10 will be u9 plus u8. So we have u9 and u8 that was given to us in the initial statement of the problem. We add them together and we have u10 is equal to 55. Before the end of the entire solution of this particular question, then we are going to take a look at something special. But for now, let's take a break. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.